Today we're going to be talking about exponential functions, and we're going to be transforming them. So whenever you transform them, you're going to see extra stuff in here. If there's no transformations, it would just be your base with the exponent being a variable. However, we have different transformations here. This number in the front will be a vertical stretch if the absolute value of A is greater than 1, and it would be a vertical compress if the absolute value of A is less than 1. This C value will determine if it's going left or to the right, if it's shifted left or right. And this one, the D value, will determine whether it was shifted up or down, translated up or down, translated left or right. Okay, also, if you have a negative in the very front, that means your graph will reflect across the x-axis. But if your negative is back here, that means it will reflect across the y-axis. So just a quick example. Your exponential function has an asymptote at 0, and then it just grows from there. However, let's say you have a transformation where it goes to the left 3, down 4, and you're going to stretch it by 5 units. Okay, you're going to multiply it all by 5. That means it'll go left 3, down 4, it'll be down here. 1, 2, 3. Your asymptote is now at -4 since it went down 4 instead of being at 0. And then it's probably going to stretch. So it's going to stretch vertically because of this 5. Now, if I put a negative in the front, that thing is facing down. Okay? So that's just an example of transformations. Let's actually graph these with exact points and not just a rough sketch. So first, I'm going to show you how to get your basic y equals 2 to the power of x. Okay, this is your basic parent function. So for x values, I'm going to plug in -3, -2, -1, 0, 1, 2, and 3. So let's figure out how to get my y values, okay? So my base is always going to be 2 for all of these. That doesn't change. However, my exponent will always change. So for the first one, they're saying the exponent is -3. So I'm going to put a -3 there. Whenever you have a negative exponent, you're going to do the reciprocal. So the reciprocal of 2 is 1/2, okay? So whenever you have a negative exponent, you're going to do the reciprocal of this number. So make it a 1/2, 1/2. And when you do that, your negative exponent will now be positive. This and this are equivalent. They equal the same amount. They're equivalent. Now, this will become 1/2. This exponent will go down to the 1 and the 2. So 1 cubed is just 1. 2 cubed means 2 times 2 times 2. 2 times 2 is 4 times a third 2 is 8. So this is equal to 1/8. Okay? Next, let's do this one. This has an exponent of -2. So for that x value, I'm going to put a -2. Remember, whenever you have a negative exponent, do the reciprocal of your base. So if you flip it, it'll be 1/2. And that will become a positive exponent now. This exponent goes to the 1, so that just becomes 1. And this exponent goes to the 2, so 2 squared is 4. Let's do this one. Your exponent is a -1. Whenever you have a negative exponent, you have to do the reciprocal. That means you flip it. It'll be 1/2. Now your exponent is positive. Whenever you have an exponent of 1, it's just your base, it's just your answer. Whenever you have an exponent of 1. Okay, this has an exponent of 0. Anything to the power of 0 is 1. You need to memorize that. Anything to the power of 0 is 1. Next, I have an exponent of 1, so this goes right here. 2 to the power of 1 is 2. Whenever you have an exponent of 1, it's just your base. 2, this is to the power of 2. This is 4. This exponent is 3, so I have 2 to the power of 3. That means 2 times 2 times 2, which is 8. Now, I could continue with this pattern if I want to. So I can put a 4 right here, 2 to the power of 4. 2 times 2 is 4, times 2 is 8, times another 2 is 16. So this would be 16. You can also go back. So if I had a negative 4, this would be 2 to the negative 4. Remember, when you have a negative exponent, you flip the base. So you flip it, you do the reciprocal. That's called doing the reciprocal. And your exponent is now positive, so that becomes 1 over 16. So notice, negative 4 will give you 1 over 16, and positive 4 will give you 16. So notice how these numbers are just reciprocals of each other. Okay? So I'm going to go ahead and graph these on my graph. Now, just to clean this up, you know the process. Now, I am going to make a clean table. So we had negative 3, and the y value, we had 1 over 8. For negative 2, the y value was 1/4. For negative 1, it was 1/2. For 0, it was 1. For 1, it was 2. For 2, it was 4, and for 3, it was 8. Okay, so that's the table that we had on the last slide. Now, it's all cleaned up for us. I'm gonna go ahead and graph it over here. Negative 3, the y value is 1/8. So at the x value, negative 3, the y value is at 1/8. That's really tiny and close to 0. That's like right here, very small. Negative 2 is the x value. The y value is 1/4. That's very small. They're kind of close together. Here's the first one, and here's the second one. There we go. Oh, it's disappearing. Next, negative 1 is at 1/2. So at negative 1, you're right between 0 and 1. 0, 1 is right here. 1, 2 is right here. 2, 4, right here. 3, 8 is up here. And remember, the 4 was a 16, and negative 4 was 1 over 16. So you're getting very tiny as you move to the left, and you're getting very big as you go this way. So that is what your graph will look like. It will never reach 0, but as you go to the left, it gets very, very small. Eventually, you'll have something like 1 over a million, right? It just gets very small, but it never touches 0. So what you are witnessing is an asymptote right here at 0. It will never touch 0, never. Okay, so really quickly, the domain, you can keep going to the left forever. So that's negative infinity, and you can keep going to the right forever. Your range, you always start at the bottom. It gets very close to 0, but it will not touch 0. So make sure it's a parenthesis and not a bracket. And then it goes up to infinity. If you're talking about end behavior, as x goes to infinity, your function, so as you move this way to the right, your function is going up. So that's infinity. The limit as your graph goes to the left. So as the x values go to the negative side, as x values go to the negative infinity, your graph is getting closer and closer to 0. So those are your end behaviors. So this is called your end behavior. And what I showed is limit notation. That's how we wrote our end behaviors. Okay? Okay, so this was for the graph y equals 2 to the power of x. Let's try another one. Let's do y equals 1/2 to the power of x. Let's try that one. So again, I'm going to use my values, my x values. Okay, so let's show the process in this middle column. My base is 1/2 for all of these. My base is 1/2 for all of these. Okay, I'll just put them in parentheses. Your exponent is what's going to change. So the exponent here is -3. Whenever you have a negative exponent, you must do the reciprocal of the base. So you're going to flip this, it becomes 2, and your exponent is now positive. 2 times 2 times 2 is 8. So this is your y column. The exponent here is -2. If you have a negative exponent, you must flip this base. So that becomes 2 to the power of 2, which is 4. -1 is your exponent. If it's a negative exponent, you must flip this, so that becomes 2. Positive 1/2 to the power of 0. Anything to the power of 0 is 1. You need to have that memorized. Anything to the power of 0 is just 1. Anything to the power of 1 is just itself. So this is just 1/2. Then I have an exponent of 2. This becomes 1/4 because 2 squared is 4. Next, your exponent is 3 and you get 1/8. So let's go over here and graph it. At -3, you're at 8. So at -3, I'm at 8. At -2, I'm at 4. -1, I'm at 2. 0, 1 is right here. 1 is at 1/2. 2 is at 1/4. And 3 is at 1/8. So you're getting very close to 0. So this is my graph. Again, I still have an asymptote right here. Okay, so let's notice something right here. When your base, this is your base. When your base is greater than 1, you're going to have a growth. When your base is less than 1, look, you have a decay. We call that decay. Okay, so that's something that we just discovered. So let's go back over here. Whenever your base, so let's just do the basic one right here. Whenever your base is greater than 1, we call it growth. When your base is less than 1, we're going to get a decay graph. It's going to decrease, a decay graph. Okay, let's do another one. Let's do f of x equals 3 times 3 to the power of x minus 1. Let's do that one. My x values, I'll just do the same thing. Okay, so let's just do a process. I'm just going to plug x straight into here. So I have 3 times 3 to the power of -3 minus 1. Remember, whenever you have a negative exponent, you have to do the reciprocal of this base. So this base, the reciprocal, you flip it, it'll be 1/3. The exponent is now positive. Everything else can remain the same. Okay, so this is 3 times 1 to the power of 3 is just 1. 3 to the power of 3 is 27. Okay, 3 times 1/27 is 3 over 27. And this can simplify to divide this by 3, divide this by 3. This is 1/9. And 1/9 minus 1, let's do that. 1/9 minus 1 is, let me make it a decimal. negative 0.888, and it keeps going. Okay, so I'll put that in here. The y value for that is negative 0.88. I guess I'll put a 9 there. It just keeps going, and then eventually it ends in 9. So I'll do that. Okay, let's try another one. Next, I'm going to make my exponent a negative 2. So I'm going to plug in a negative 2. Remember, negative exponent, you have to do the reciprocal of that base. So that's 1/3. This is now a positive 2. Everything else can just come down. This becomes 3 times 3 squared is 9. 3 times 1/9 is 3 over 9, which simplifies to 1/3. And 1/3 minus 1 is negative 2/3, which is approximately negative 0.67. So this is negative 0.67. Okay, now let's do negative 1. Okay, so I have 3 times 3 to the negative 1. Remember, negative exponent, you must flip this. 3 times 1/3 is 1, minus 1 is 0. So you get a 0. Next one, the exponent is 0. 3 to the power of 0 is 1, remember. So this is 3 times 1 minus 1. 3 times 1 is 3, minus 1 is 2. So that's 2. Once you get to the positives, it's much easier. You don't have to do the reciprocal. Okay, next. The exponent is 1. 3 to the power of 1 is 3. Times 3 is 9. Minus 1 is 8. Next, you have the exponent is squared. 3 squared is 9. 3 times 9 is 27. Minus 1 is 26. Okay, this is starting to go off of the page. So it's growing exponentially. 3 times 3 to the power of 3 minus 1. That's 3 times 27. 3 times 27 is 81. Minus 1 is 80. All right, so we have our table. Now we can graph it. Negative 3 is down here at negative 0.88. That's about closer to negative 1, but not touching it. Then at negative 2, you're at negative 0.67. Then at negative 1, you're at 0. Then at 1, you're at 8. Oh, at 0, you're at 2. Okay, so next we have at negative 1, you're at 0. At 0, you're at 2. And at 1, you're at 8. And at 2, you're way up there. This is exponential growth. And you see it, because look, you have a minus 1 right here. That means your asymptote is right here at negative 1. And you see it in your graph. So that is your transformation. I hope you learned something.